Networking represents the fundamental infrastructure that enables modern hacking operations, serving as both the attack surface and the communication backbone for cybercriminals. Every successful hack begins with network reconnaissance, where tools like Nmap and Wireshark become extensions of the hacker's senses, probing target networks to identify vulnerabilities, map infrastructure, and analyze traffic patterns. These network scanning techniques have evolved into a sophisticated science, incorporating TCP/IP stack fingerprinting to identify operating systems, service version detection to pinpoint outdated software, and passive monitoring that leaves minimal forensic traces. Hackers approach networks through the lens of the OSI model, exploiting vulnerabilities at every layer, from MAC address spoofing and ARP poisoning at the data link layer to DNS cache poisoning and HTTP request smuggling at the application layer. Wireless networks present particularly fertile ground for attackers, with tools like aircrack enabling WPA2 encryption cracking, rogue access point creation, and evil twin attacks that mimic legitimate networks to harvest credentials. The hacker's understanding of network protocols borders on the philosophical. They see beyond intended functionality to recognize how protocols like DNS can be abused for data exfiltration, how ICMP packets can carry command and control messages, and how BGP routes can be manipulated to hijack internet traffic. This deep protocol knowledge allows attackers to bypass conventional security measures by hiding malicious activity within rarely monitored protocols like SMB, SNMP, or even industrial control system protocols such as Modbus and DNP3. Modern network intrusion frameworks like Metasploit have democratized advanced hacking techniques, providing pre-built exploits for everything from router vulnerabilities to VPN weaknesses, enabling relatively inexperienced attackers to launch sophisticated network assaults. Authentication protocols like NTLM and Kerberos have become prime targets through password spraying attacks that test common credentials across entire domains, while pass-the-hash techniques allow lateral movement without needing to crack passwords. The cloud revolution has created new network attack surfaces that hackers quickly learned to exploit. Misconfigured S3 buckets, exposed API endpoints, and vulnerable container network interfaces all provide entry points into what should be secure environments. Software-defined networking, while offering administrative advantages, has introduced new risks as hackers target centralized controllers that serve as the brains of modern network architectures. Even more disturbing is how hackers have begun weaponizing network time protocol servers to disrupt forensic investigations and manipulate timestamps across entire organizations. The Internet of Things has expanded the attack surface exponentially, with poorly secured cameras, routers, and smart devices being conscripted into botnets or used as pivot points into more sensitive networks. Command and control infrastructure has evolved into an art form among advanced hacking groups, moving far beyond simplistic IRC botnets to sophisticated architectures designed for resilience and stealth. Modern C2 channels employ domain generation algorithms that create thousands of potential rendezvous points, fast flux DNS networks that rotate IP addresses rapidly, and peer-to-peer communication that eliminates single points of failure. Hackers increasingly hide their traffic within legitimate cloud services, using platforms like GitHub or Dropbox as covert communication channels that blend with normal web traffic. The dark web provides specialized bulletproof hosting services in jurisdictions with lax cybercrime enforcement, offering everything from DDoS-protected servers to VPN services with no logging policies. Network obfuscation techniques have grown remarkably advanced, including domain fronting, which uses major CDNs as proxies, TLS tunneling to encrypt malicious traffic, and timing attacks that spread activity over extended periods to avoid detection thresholds. Blockchain-based DNS systems and decentralized hosting platforms now offer hackers infrastructure that resists traditional takedown efforts, while cryptocurrency payments preserve anonymity in these underground network marketplaces. Network-based attacks demonstrate frightening creativity, from supply chain compromises that poison software updates delivered through legitimate distribution networks to advanced man-in-the-middle techniques that go beyond simple ARP spoofing. VLAN hopping attacks breach network segmentation, while compromised hypervisors undermine virtualization security. Industrial control systems face specialized threats as hackers manipulate Modbus and DNP3 protocols to potentially cause physical damage to critical infrastructure. Nation-state actors have begun experimenting with attacks on core internet routing infrastructure, including BGP hijacking incidents that redirect entire countries' worth of traffic through hostile networks. Even air-gapped networks, once considered impenetrable, have fallen victim to ingenious exfiltration techniques using electromagnetic radiation, thermal patterns, or even fan vibrations as covert data channels. The cybersecurity industry has responded with increasingly sophisticated network defenses, but hackers continuously adapt. Next-generation firewalls with deep packet inspection meet advanced encryption and traffic fragmentation. Intrusion detection systems are fooled by polymorphic network traffic that changes signatures dynamically. Network behavior analytics face attackers who meticulously study and mimic normal traffic patterns, sometimes compromising monitoring tools themselves to blind security teams. The Zero Trust model has gained traction as organizations recognize perimeter defenses alone are insufficient, but hackers already develop techniques to abuse trust algorithms. Software-defined perimeter, or SDP, technologies attempt to make networks invisible to unauthorized users, yet attackers find ways to discover and exploit them through compromised credentials or insider threats. Looking ahead, networking for hackers will leverage emerging technologies in dangerous new ways. AI-powered attacks may automatically adapt to network defenses in real time. Quantum networking exploits could eventually break current encryption standards. 5G network slicing vulnerabilities might allow attackers to infiltrate critical communication infrastructure. As edge computing and IoT devices proliferate, they create vast new attack surfaces at the network periphery. Network function virtualization introduces new risks as critical networking components become software-defined. Intent-based networking, while promising improved management, could be manipulated to an attacker's advantage if compromised. The ongoing arms race between network attackers and defenders shows no signs of slowing, with each technological advancement introducing both new protections and potential vulnerabilities. What remains constant is that network knowledge equals power in the digital age, and today's hackers continue demonstrating remarkable ingenuity in acquiring and weaponizing that knowledge. As long as networks exist, there will be individuals finding innovative ways to exploit them, making network security one of cybersecurity's most dynamic and challenging frontiers. The only certainty is that the cat-and-mouse game will continue escalating, with networks serving as both the battlefield and the prize in this endless digital conflict.